Good morning. We are so glad to have you here. Welcome to the 2021 Math Institute. We are glad to spend the day with you. A couple of things to know: this webinar is being recorded and it will be posted on our ABE PD YouTube channel. And also, if you have any tech concerns, Marisa Giesler, our operations manager, is your go-to this morning. It will be someone different in your afternoon sessions, so take a look at those slides when they come up. But this morning, any tech issues, chat to Marisa. And a reminder, please use your first and your last name, just like you would if we were in person and could be pouring you coffee and give you a name tag and a paper flyer. Of course, not quite there yet this year, but we do want to know who you are. So please use your first and your last name. I am sure you have all been Zooming a lot in recent months, but just a reminder, if you use another platform, that the mute and video buttons are at the bottom of your screen. You can rename yourself if you need to add your last name. For example, sometimes people come in with like staff names for their Zoom. Open your chat box and keep it open. One thing we notice is that the chats sometimes come fast and furious and they disappear, but if you keep your chat box open, you can even enlarge it. You'll be able to keep track of what's happening. If you would like closed captions, you can enable those at the bottom of your screen as well. And I want to be sure and introduce Gail and Marisa. Gail Rutan is our events manager. She is hosting these sessions today and is helping us with all of the tech stuff behind the scenes that makes everything go smoothly. And Marisa Giesler is our operations manager, and she is also supporting us today. Thank you so much, Gail and Marisa. And you may not know, but we have an A team here in Minnesota. Andy, Carl, Katie, Amber, Justine, Megan, Tom, Cindy, Rebecca, Mark, and Marcy, and are all part of this team. And I didn't introduce myself. I'm Patsy Egan. I direct Atlas. We are housed at Hamline University in St. Paul, and we are just delighted to collaborate with so many math people and excellent adult educators around the state. So thank you so much to the A team. Just a few things to keep in mind. We do, of course, expect you to use your first and your last name. We don't need to tell you this, but we do want you to be respectful both to your presenters and to your colleagues. And of course, use your camera and mic as you're invited to do so. If you feel comfortable, obviously not required, but particularly in breakout rooms, we will ask that you do that. When you're in a large group like right now, please keep it off though. Thank you. Some sessions are recorded. We'll always let you know. The flyer is like magic, so you're going to want to keep track of that flyer. The link you used this morning is the one you'll use until lunchtime, and then in the afternoon, you'll need to use the flyer to navigate to your afternoon sessions. And that is also where you will find the evaluation link, which is your pathway to your CEUs. So as long as you fill out the evaluation, you will be able to get your CEUs. And couple things to, just like this little kiddo, be aware we're going to ask you to be on camera sometimes throughout the day. This is not just a listen and kind of do other things kind of day. We're going to get you involved. You're going to do some mathy goodness today. So we want to be sure that if you're able and willing to be sure to turn your camera on so that you can participate fully. And a couple of announcements. So lots of great PD coming to you, to your living room, wherever you are able to zoom into different things. The first thing we want to be sure you know about is the CCRS time to refresh. So if you are involved with CCRS work in any way, we would love for you to join us on October 7th for an excellent session that will have both math and ELA content. And then on November 5th, in lieu of regionals, which we are not able to do in person quite yet, we are having a virtual conference on Friday, November 5th, and I hope you'll be able to join us for that. And Mighty Networks is a fabulous way to stay connected with your colleagues. This replaces our old Schoology group. And Mighty Networks is a networking platform where you can join the math and numeracy group and stay connected beyond this conference with your colleagues and talk about all things math. And someone will drop the link there for sure. And I want to introduce the mastermind behind today's conference. Lindsay Poost is our numeracy coordinator. Lindsay, thank you so much for all your work putting this together, and I'll turn it over to you.
Yes, thank you so much. It's here. I can't believe it's here. So welcome everyone. We are excited to have you. And we have some great sessions in store. A few objectives for today that I want to share. We really want to focus on the why behind some math topics. So being able to articulate the why behind the rules of fraction operations and specifically cross multiply and divide when working with proportions. And being able to identify ways that we can use these same strategies with our students. We're going to get to practice some strategies today. And the goal is to enhance conceptual understanding. And then being able to just share with someone else, like spread the mathy goodness beyond today, the importance of building conceptual understanding and coherence with our students. So those are the objectives that are guiding today. What you're going to experience today, we are going to have 2 keynote workshops with Elizabeth Peyser. And we are going to start with fraction computation on a number line. We will then take a break and then we will focus on moving beyond cross multiply and divide. We will have a lunch break. And then in the afternoon, there will be 4 concurrent sessions to choose from. And they are all tied to the morning workshops. So you can use your flyer to read the descriptions and choose, and they will all be repeated a second time. So you have 2 choices out of 4 this afternoon, and then we will wrap up at about 3 o'clock. The last thing I want to mention before I bring on Liz is this Padlet. And this Padlet is, I put resources on here instead of having to chat out a bunch of links for the different mathy things we're going to be doing, but we're also going to be adding to this. So if there is something you're like, oh, that would be great if that was on the Padlet, please let me know and we can put it on there. That's why this other resources is there. I put a column here, related CCR standards from today. So for the fraction computation on a number line, there is a document there you can click on and see what kinds of CCR standards are kind of being referenced or are related to this morning session, this first session, and then the second session, the same thing. So really being able to tie it back to the CCRS. And then for the second session, not the first, the second session after break, you will want access to these 3 handouts. If you have access to a printer, you can quick print them. Otherwise, you can pull them up and look at them and be able to engage that way as well. So you will want this link to the Padlet. We will put it in the chat throughout the morning. And again, we will be adding resources as we go. All right, so let me, without further ado, introduce Elizabeth Peyser. She is a National Director of Content and Implementation at Curriculum Associates. She specializes in training K-12 educators to interpret progressions in mathematical standards. And prior to her current position, she was Vice President of Middle Schools for the Kansas Association of Teachers of Mathematics and the K-12 Math Coordinator for Wichita Public Schools. During Kansas's transition to the Kansas College and Career Ready standards, she developed math clinics for teachers that became the statewide training program. And some of us may have seen her from at MCTM with her session, The Arc from Arithmetic to Algebra, and we know her and love her from there. So without further ado, Liz, I will stop sharing and you can share your screen. Thank you for being here.
Wow. Hello, everybody. Wow, this is amazing. Thank you so much. What an amazing group. And I love all the references to mathy goodness. I'm going to start using that. Mathy goodness. I love that. Okay. Am I sharing? Am I presenting?
Yes. Now you're presenting.
Okay. And the live caption. All right. I turned off my subtitles because you have the closed caption if people need that. Okay, so we're good. Okay, sorry, let me open the chat.
Yeah, everything looks and sounds
sorry.
good.
I just have to arrange everything on my second monitor. Okay, I think I'm ready to go. Okay, well, hello, everybody. Thank you so much for joining us. This is really exciting to talk to you. about progression. We're going to look at fraction computation on number lines. And just a little bit about me. I work for a company called Curriculum Associates, and we produce K through 8 materials. So we have a core curriculum for mathematics. We also have a diagnostic that runs K-12. I know this is a little bit outside of your population that you work with, but you might have students, your own children, in using some of our materials in the Minnesota schools. And then math is math. So we run, not only do we have these the curricular materials, but we also run these types of webinars nationally. And we actually have one coming specifically for Minnesota, that arc of arithmetic to algebra. We're doing that in Minnesota. And so my colleague, Brendan Thompson, I live in Kansas. Brendan is local and he's in Minnesota. So he's on the line, and we'll drop those invitations in the chat. So if you like these sorts of things where we run through a progression, we have several opportunities, all free, coming up. So we'll get those flyers to you. Awesome. Okay, so let's take a look. We're going to talk about number lines. So this will be a participatory event. So get your paper and pencil ready, get that fractions breakout handout on the Padlet. We're going to be using those materials. So strap on your seatbelts and get ready to go. And we're going to, with me, if you participate in the arc of arithmetic to algebra, you know, with me, we always start with math. So here we go. First math problem. A butcher wants to divide 3 pounds of meat into packages that will each contain a ½ pound of meat. How many packages can she make? So go ahead and figure that out. Type your answer in the chat, but don't hit send. Give everybody a chance to think. Work that out however you want to. All right, go ahead and hit send. Woo, look at these mathematicians. 6 packages of meat. 6, nice, very nice, good job, good work. So I'm curious if anybody, I think I saw a few come into the chat. How did you find your answer? So each pound gets divided up into 2 pieces. I see Mark put in. How did you find your answer? How did you think about this? If anybody wants to type in the chat. Ooh, Marcy, I love that question. How many halves are in 3 wholes? Wow, ½ of 3 is 6. ½ of 3 is 6. Tell us more, Norris. Because I want to think about ½ of 6 is 3. You've stumped me. 2 halves make 1. Oh. So it's like we're making halves, but we're actually like multiplying. Isn't it weird? It like messes with my brain. We're dividing, but we are like multiplying. I made 3 bars of the same size and broke them into halves. I had 6 sections. Okay, visualize cutting 3 chunks of meat and cutting each one in half. I love the visualization. Thank you, Elizabeth. 3 divided by 1/2. All right, great thinking, great thinking. Okay, I don't know if anybody did this on a number line, but I did see a couple people say they envisioned three groups of like 3 of something. So I wrote a number line out. So I have 0 to 3. And then as somebody put in the chat, several of you put in the chat, each whole gets partitioned into 2 halves. So each one of these whole pounds is partitioned into 2 halves. So we end up with 6 ½ pound packages. because even though we're dividing, we actually are making smaller pieces. So it's kind of like we're increasing everything by a factor of 2. It totally messes with my brain. So great work there. Great. All right. So this is actually a 5th grade fraction problem, which I believe is your level C, if I'm correct on that. Somebody could, yes, Lindsay says yes. Okay. So this one is actually a level C problem. So in order for students to do this level C problem, my question for you is, what types of knowledge around number lines do students need before they tackle this level C problem? So what kinds of ideas, like just what thinking about number lines would they need? Why should I use a number line? Why use a number line? Increments, equal spaces. They do need a background knowledge on division. Thank you. A tape measure. Love that. Love that. Equal spacing, patterns, counting sections, not the lines. I love that. You guys know where we're headed in this. Fantastic. Great. So there is this really confusing issue with number lines. You know, do I look at the spaces? Do I look at the tick marks? We have tick marks and spaces. It's very confusing for kids. They want to draw on the tick marks and count those when really we're talking about counting spaces. So, and we'll dive into this a lot today. We land on a tick mark, which marks a number after we travel that whole space. And the tick marks really delineate where the whole starts and ends. So when we're working with fractions on a number line, we really need to delineate where is 0 and where is 1. And then I'm partitioning that whole space into partitions, making up that fractional part. Equal spaces, somebody put equal spaces in the chat. Equal spaces represent unit fractions. And then we work with these unit fractions to do all kinds of computation. And then as somebody put in the chat, this is applying and extending previous understandings of division. So that idea of partitioning and fair sharing. And then it looks a little different, you know, with fractions, but it is the same question. How many, and somebody put that in the chat, which is a great question. How many halves are in one whole, or how many of this are in that? So we are talking about division. All right, awesome. So let's go ahead and draw some number lines. Somebody wrote in the chat a question, why use a number line? Which I'm not sure if that was rhetorical or not, but but it is a question you'll probably get. Why do I need to use a number line? So number lines for fractions are fantastic because the tape measure that somebody put in the chat, we use fractions, we use rulers and tape measures as measuring tools, and a lot of your students will, you know, are using these in their careers. And so we do want to explain that measurement, that fractions are numbers on the number line, and they move to the right, they increase in value as they move to the right. And when I travel from 0 and I land on a number on the number line, a fraction is a point on the number line, and an equivalent fraction occupies the same spot on a number line as the other fraction. So lots of implications in terms of just a linear view of numbers. Humans have an innate sense of a linear view of numbers. It actually starts very early. We have this linear timeline where numbers move to the right. And so children, they learn this, they have this innate sense of number. And so they might not know exactly where the number 5 is, but they know that there's something bigger is going to be more to the right. So really interesting brain research around number sense, and working with fractions on the number line just really uses that innate knowledge and then furthers it so that students can do upper level mathematics. So hopefully, Elizabeth, gave you some fodder to tell your students, and let me know if you want any more information about that. And then I saw somebody positive and negative. Yeah, so we've got positive and negative numbers. So numbers that get smaller move to the left, numbers as we get bigger move to the right. So we're just expanding that whole idea of that linear sense of numbers and using fractions. Great. Okay, so let's go ahead and draw a number line. So pick up your pencil and just draw a line. If you've never done this before, now's your chance. We're going to do a lot of this today. And let's delineate between 0. Let's see, I'm going to draw some tick marks. I'm going to put in 0, 1, 2, 3. So here's a basic number line representing whole numbers. And I have equal spaces, so 0 to 1. Go ahead and trace with your finger and start at 0 and then make a whole jump and land on 1. And then with your finger, start with 1 and make a whole jump and land on 2. And that's the action we want students to do. So they're traveling the space. I can't land on the number 1 until I actually travel that entire space. I have to travel the whole space and then I land on a tick mark, which marks the number 1. If I travel 2 whole spaces from 0, 1, 2, I land on a number called 2 on my number line, but I have to travel the spaces first. So the tick marks are really just marking where you start and where you land, but it's the space that's important. Okay. Okay, so that's a basic number line. Travel the space, land on the number. But now let's zoom in and see what's happening between 0 and 1. So underneath your number line, draw some dotted lines. So in this space between 0 and 1, we're going to zoom in. So just kind of zoom in and draw. We're going to look more closely at this space. So you're just making the space between 0 and 1 bigger so we can do some work with it. And I love this idea of zooming in. I think this is really helpful for students. Okay, so in between 0 and 1, now we're going to partition this into unit fractions. And I'm just going to partition this one into thirds. So between 0 and 1, I need 3 equal parts. So for a moment, think about that. How many tick marks would you need to make 3 equal parts that are spaces? So I'm not going to need 3 tick marks. I'm only going to need 2 tick marks. So I just kind of try to eyeball 3 equal spaces. So I've put 2 tick marks in. Okay, so a couple of important things for fractions. We have to delineate 0 and 1 with tick marks. So make sure you have a 0 and a 1, which is marking that whole space. And then in between that whole space, I partitioned it into 3 equal spaces. And I used 2 more tick marks. So now I have 3 equal spaces in that whole space. Nice job, folks in the chat. 2 tick marks, you got it. All right, so now when I start at 0 and I travel to that first tick mark, I've traveled a space that is 1/3 in size, 1/3 of my whole. And when I travel that, I can land on the number called 1/3. If I travel a second space of size 1/3, I then land on a number called 2/3. And then if I travel that third space of size 1/3, I land on a number called 3/3, which also occupies the same spot as 1. So 1 whole is 3/3 in this particular case. They're equivalent fractions. They occupy the same place on the number line. All right, great. All right, so just to kind of back up here. So in level A with your students, in level A, they've learned about numbers and position, and they've established a linear view of numbers, probably along a number path. And so they're introduced into this whole idea of spaces. In level B, they've been introduced to numbers on a number line, including 0. So 0 and then whole numbers on the number line. So that brings us up to level C, where they're introduced to fractional parts. Okay, awesome. So in our session today, we are going to introduce you to level B in 3rd grade, what basic equivalents are and unit fractions, and understanding just what makes an equivalent fraction. Then we'll work up through level C and talk about some computation. And then in level, and then C and yeah. Okay, so I put the grades on there so that you can see what's happening, maybe with your own students or just, you know, to match it up with their grade levels. So with your own children. So it's interesting because things are introduced in one grade and then deepened in the next grade. So if you understand, if you take a look at the basic equivalents, they're understanding equivalent fractions in 3rd grade, but then they actually formalize an algorithm around equivalent fractions in the 4th grade. Same with addition and subtraction and multiplication. They're introduced to that in 4th grade. They begin to work with like denominators, and then they deepen their understanding and move on to unlike denominators for addition and subtraction in the 5th grade. So fraction computation in the K5 spectrum, K6 spectrum, is spread out over several years, and the majority of the fraction computation is done in elementary school. Middle school students are only doing a 1 standard division of fractions by fractions. And then in your world, the majority of it would be accomplished in level C. Okay. Okay, awesome. All right, so here we go. We're going to understand the basic connection, understanding the connections between the levels. So if you have a student at level C, but might need some prerequisite work around level B, this will give you a sense of what some of those concepts might have been, so you can infuse that into your instruction. And then the other outcome for today is to help you see how the algorithms that we all know and love, how those are connected to visual models and conceptual understanding. I know I was taught algorithms and I really didn't understand the why behind it, but as Lindsay said at the beginning, we really want to help students see the why behind it, because not just because it deepens understanding, but it gives kids and students and adults something to fall back on if they forget, and it gives them a way to reason through it. Is this even reasonable? Is my answer reasonable? So thinking about the butcher problem, you know, would it be 3 or would it be 6? Or so just kind of like, what would be reasonable? Because I can think about this situation, and as you explained in the chat, I'm taking each pound and partition it into 2. So just giving them a way to see if their answer is even reasonable. Okay. All right. So let's draw some more unit fractions. So on your paper or on your handout, go ahead and draw some number lines. Do 3 of them, and I'd like you to practice. So on the first one, partition it into halves. On the second one, partition it into thirds. And on the third one, partition it into fifths. So you're always going to have a hole between 0 and 1. And then just do 3 different partitions, halves, thirds, and fifths on each separate line. So the first line will have halves, second line will have thirds, third line will have fifths. Okay, so hopefully halves, you just did one right in the middle. So I have 2 equal parts. Each part is size 1/2. So we read this as 1 over B or 1 over 2, because the whole was partitioned into 2 equal parts. Pretty basic, but it's also kind of complicated. What is a fraction? The fraction is when a whole is partitioned into B equal parts. So for thirds, thirds, we need 3 equal parts. So I have my 0 and 1 and put 2 lines in. The thing to notice, the students, this does not have to be perfect. Yeah, and they really struggle with that too. So excellent. I love that, Andy. Just make sure that they don't have to be perfect. You're just kind of eyeballing it. Absolutely. All right, and then the last one, now this is where I really like thinking of Andy's comment here. So for fifths, here's my trick. I look at my whole and I make my first tick mark. Oh, I guess I had something to say about 1/3. So we travel 1/3, we land on the tick mark called 1/3. We did that earlier, so I think you guys get the point. Okay, so for fifths, I look halfway and I make a mark a little to the left of the halfway point. And so I have a small space and a large space. So in the small space, I try my best to make that into 2 equal parts. And then on the large space, I try to make it into 3 equal parts. So I actually tackle it in 2 stages. So I end up with 5 equal parts, but I start with a little bit less than half. There we go. Great. All right. Yeah. Fifths are hard with circles too, Marcy. I feel your pain. So if I start from 0, I travel 1 of those equal parts, I land on the number 1/5. If I travel 2 equal parts, I land on 2/5. If I travel 3 equal parts, I land on 3/5. Yeah, absolutely, Kevin. Love that. Great. Okay, so let's talk about equivalent fractions. So this is where we do need to try to be as precise as we can. So on this one, try halves, fourths, and sixths. So go ahead and delineate 0 and 1 and do halves, fourths, and sixths. Okay, so let's take a look. So halves, right? You just did that one earlier, so you're familiar with that one. Partitioned it into 2 equal parts. For fourths, I like to go halfway and then half of the half and half of the other half. So I end up with 4 equal parts. And then for sixths, I divide it in half and then I look at the left-hand side and I make 3 equal parts over there. And I look at the right-hand side and I make 3 equal parts over there. So again, I do that in stages. I do the same for tenths too. Okay, all right, so equivalent fractions occupy the same place on the number line. So this is where that linear view of numbers and the number line really comes into play. So if I start at 0 and I travel one space of size 1/4, I land on a number called 1/4. If I travel 2 spaces of size 1/4, I land on 2/4, which also occupies the exact same spot on the number line as 1/2. So students are introduced to this in level B, that equivalent fractions occupy the same spot on the number line. And then for sixth, it would be the same spot as 3/6. So they can see that, and you can make equivalent fractions. There's a lot of really great activities where they fold paper and make fractions. There's also some really great manipulatives with the fraction towers. I really like fraction towers, or those fraction bars that come in the plastic. It's like a plastic frame. But the important part here is that the whole needs to be the same. So do that. All right, so we're gonna just do a little bit more practice. So go ahead and pick one of your number lines, put your finger on 0, jump to the next tick mark and say the name of the fraction that you land on. and then jump again. So it's that importance of traveling the spaces, and then you land on the tick mark that says the name of that fraction. Okay. So I wanted to just pause here and see what your thoughts are around the tick marks. Are there misconceptions students have? And what kinds of, how do you see this as helping clear up some misconceptions? Or what questions would you ask kids to help clear up misconceptions? You may have answered this question, but would you start with students drawing the tick marks, or would you start with tick marks given and then move toward that? They often count the tick marks rather than the gaps. Yeah, okay, so Catherine, great question. When I like to start with the whole, so I like to have them mark 0 and 1, those tick marks, and then they're looking at that space. And now the question is, okay, so that's my whole. I want to partition this space into 3 equal parts. What would that look like? So they've delineated where the whole starts and ends. And now they're looking at that space, and I want equal marks. So I think I would start there. But I'll throw that out to the audience to see what it was from Catherine put in. You may have answered this, but would you start with student drawing the tick marks, or would you start with tick marks given and move them toward that? I'm going to just read the chat here. So let's see. So counting 0 is the first. Yes, counting 0. So it's they start at 0 and they can't, that's their starting point. So what Andy said, they start there and then they jump to the next tick mark. And then when they land, that tick mark marks the space that they jumped. It could be a whole number. Maybe they jumped one whole space. It could be that they jumped 1/5. But it's what they land on. They have to travel the space. They can't have it until they travel it. It's like I can't, you know what? Let me switch over to my document camera. And I think this is an activity that might help your kids. Hopefully you can hear me. So in level A, they learn about a number path. And a number path looks like this. And so students would take markers or counters and place them on there. So I have two items, and so that corresponds with the number 2 on the number path. But I have to cover that whole space in order to have 2 items. I have to cover the whole number path, the whole space. So they're thinking about this space idea. So I think it's in level B, they transition to the number line. Well, there is no 0 on the number path, but we help students see the 0. Well, where would the 0 be? It would be right here, 0. And then if I have a number line and I have 0 here, this would be the number 1, but I can't have that 1 until I cover that space. So they have to travel that whole entire space to have that one object. In order to have 2 objects, I have to actually travel that whole entire space, and I can land on the number 2. So that might be an activity that might help that. Let me know if that is helpful. Yeah, right? You can't complete the 26. You can't complete the first mile unless you've actually left the starting line. Great. Okay. Oops, get back here. Awesome. Okay, was there anything else in the chat? Different color tick marks. Yeah, I love that idea, Jessica. I'm a big believer in as many visual models as possible. So color coding, love it. Yes, love the idea, Lorna. The unfold the strips, mark where 0 is, and then mark the tick marks. Yeah. So again, with the folding of the strips, where's the 0, where's the 1, and we partitioned that space into equal spaces. Love it. Love the color coding. Ah, so great. Great ideas. Okay. All right. Here's another hands-on activity you can do with grid paper, because as somebody put in the chat, it's really hard for them to line up the lines. So let's use grid paper. Now you're a little limited depending on how many spaces are on the grid paper. On this one, I had 12. If you can get grid paper that has 24 spaces, then you can even put eighths in there. But here, I delineated, if you take a look at the picture, 0 and 1, and I did 1, 2, 3, 4, 5 different number lines underneath each other, but the whole is the same. And the first one I partitioned into 12ths. So I have 12 twelfths. The second one I partitioned into halves, the third one into fourths, the fourth one into thirds, and then sixths. And so you can just do this, have them practice partitioning, and then you can have them practice identifying equivalent fractions. So I highlighted 1/3. So I landed on the number called 1/3. What is an equivalent fraction for 1/3? And there are a couple of them on here so the students can see 1, 2, 3, 4 twelfths, as well as 2 sixths. Yep, turn the notebook paper sideways, love it. And then you've got the lines, delineate the whole. You can do several, you can do 12 lines, and then underneath have them do equivalent fractions. And if you get 24 lines, you can do a whole of 24 spaces. You can get eighths that way if you do that. So, and then you can do thirds and ninths if you want, with something like 18 lines, halves, thirds, sixths, thirds. I guess you need 27 lines for ninths. No, 18, you can do 18. Just thinking to help understand spacing of students do a standing long jump, measure the distance where they started. Distances. Great ideas. Love that. Get the physical movement in there. Okay. All right. We're feeling okay about unit fractions. Okay. So let's do some computation. So Josie and Margot are painting a fence green. Josie starts at one end and paints 3/10 of the fence. Margot starts at the other end and paints 4/10 of it. What fraction of the fence do they paint all together? Don't hit send just yet. You can type your answer in the chat, but don't hit send. What fraction of the fence do they paint all together? All right, go ahead and hit send. Look at these mathematicians. I love that. Awesome. 7/10. You got it. I do want to go back to that last chat before you all hit 7/10, which is about using the tiles on the floor. I love that idea. And in my head, I thought you could maybe even mark a 0 and 1 on the floor. So you have your hole, and then the tiles could be those different parts. So it's like that grid paper activity on the floor. Love that. All right. Great job with the 7/10. Nice work. Let's actually talk about how the different representations we can do with this. So students might, you may have done an equation. You may have done a regional model, such as ands with a circle, trying to partition that into tenths. Or you may have done something with a set model that we see in the middle there with 10 tiles. and representing a set of 10, and how many out of the 10, 3 and 4 were Josie's. Or maybe you drew a picture representing the fence. So we see that at the bottom on the pink with the picture. I know, right? It's kind of a funny problem. And then we see the 3 unpainted boards in the middle of that picture there. So using pictures, using color coding, we want students to visualize the situation. I think so often we give students problems and they just automatically find the numbers. I call them number pluckers. They pluck the number out and then like pick a random operation. And so we really want them to help visualize the situation. And, you know, just a great technique is like, hey, you know, what are you visualizing when you read this out loud? What's the setting? What are the characters? What's the action? Like I always ask students that. Hold on, I know there were some numbers in there, but I want to know what is this about? Like, what's the setting? They're painting a fence. Who's painting a fence? Girls are painting the fence. Okay, so, you know, tell me more about that. So just kind of ask questions to help them visualize the situation. So here, then we can go into, all right, well, what does that look like? I see a fence. Just like somebody said, Jessica, they're painting from one side, one's coming from the other side. They're kind of going to meet in the middle. Okay, cool. So how much have they painted? So we just want them to visualize what's happening. A fence is linear. So this is kind of interesting. This problem lends itself to using that linear form of numbers. And we saw that linear drawing from one of our students there. So let's go ahead and use our number line for addition. So let's do this. So what I'd like for you to do right now is on the top number line on your screen, put your finger on the number 0. And we have that hole, and the hole has been partitioned into 10 equal spaces. So start at 0 and let's jump, I think it was Josie. Let's jump 3 equal spaces of size 1/10. So jump 1/10, 2/10, 3/10, and you land on that red dot that marks 3/10. So now we're going to start there and we're going to add 4/10, which was Margot's part. So start at the 3/10 and make 4 jumps, and you should land on 7/10. So you can just do that right on your screen. Hopefully everybody landed on 7/10. Okay, great. So this corresponds to that linear drawing that a student did. However, my question to you is, where are the 3 unpainted boards on the number line? Where are the 3 unpainted boards on the number line? Go ahead and type that in the chat. They are at the end, and in the fence drawing and in the picture, they were in the middle. Why are they at the end on the number line? Interesting. Why are they at the end? I know this seems like really simple for us. Like, oh, they're going to be at the end, of course, but it's actually kind of a, you know, something we really have to point out to students. This whole idea of concatenation, which is we can have segments, but we actually have to put them together and concatenate to get that entire space from 0 to how far we've traveled. So we take these two, a 3/10 segment and a 4/10 segment, and when we're talking about distance, we have to concatenate them and put them together. So I start at 0, I do my 3/10, and then I have to start from the 3/10 and count the 4/10. I can't have any gaps on my number line or else it's going to be all messed up. So I start at the 3/10 and I count the 4/10. Now, the interesting thing here is this is exactly what we do when we do whole numbers. So when we add fractions, we're doing the exact same thing as we do with whole numbers on the number line. We're starting with the 3/10, and then I'm going to start there and then add my 4/10 from exactly where I started. And I land on my sum. That's the number that I land on is the sum of that concatenation of parts. It's the same as adding whole numbers. Okay, let me know if you have any questions about that. Concatenation. I love it. Hung Sai Woo. If you're interested in reading math, Hung Sai Woo is a mathematician. I think he's retired now out of the University of Berkeley. I will put his name in the chat for you. You got it. And in Excel spreadsheets, concatenation, like when you want to link different rules and different cells together, you do a concatenation as inside your Excel spreadsheet. Because I'm an Excel spreadsheet person. Love pivot tables. Awesome. All right. So the next thing we want to do is connect the visual model with the more abstract number model. So color coding is my friend here. I'm showing the parts. I 3/10 plus 4/10 equals 7/10. The students can do the action on the number line, write down their number model, and their sum is 7/10. So we don't always want to connect that more abstract algorithm with the visual models. Okay, great. All right, so let's actually talk a little bit about creating equivalent fractions. We're going to do a couple of different activities here because our next computation is going to be adding with unlike denominators. So students will need to substitute a fraction with another fraction to create a situation where they can add the same size parts. So we need to help them understand how we can create equivalent fractions. So right here, this is gonna, all right, here we go. So just take a look at these two bar models. You'll notice the top one is partitioned into halves and the bottom one is partitioned into tenths. So halves and tenths, okay? All right, so the whole, of course, is the beginning and the end of the bar. So I'm just going to line this up with a number line. So these are bar models, but I do want you to see how this would look on a number line. 0 and 1. So think about where would the half be on the number line. Go ahead and mark it on just put your finger on your computer screen. Where would that 1/2 be? And then the tenths, where would those tenths be? They would be the right side of the boxes. Okay, so there's my half, and then tenths, I would partition down at the bottom with my tenths like that. Okay. All right, so if I have 1/2, my half would cover up half of my top bar and half of my bottom bar. Okay, so I have 1/2. I'm halfway between 0 and 1, and I've covered up half, which I've also covered up 5/10. So 1/2, and I've covered up 5/10. On my number line, it would be 5 of those tenths. Okay. All right, so I'm going to zoom in here and do this again. So I have my half. So why is it 5/10 as well? And why are they equivalent fractions? So in my bar, I partitioned it into 2 equal parts. And then my second bar, I partitioned the same bar into 10 equal parts. So even though I have 10 parts, they're smaller parts because I partitioned everything. I increased the number of parts by a factor of 5. So in my denominator, instead of 2 pieces, I have 10 pieces. They're smaller, but there's 10 of them, and I increased it by a factor of 5. Okay. So 5 times 2 equals 10. So my denominator has been increased by a factor of 5, not because these pieces are bigger. I didn't make it bigger. I actually made the pieces smaller, but the number of pieces has been increased by a factor of 5. The number of pieces. Okay, So I cover up my half. So I have 1/2, which is also 5/10, because the number of pieces I covered up, 1/2, there are 5 pieces in there. So that has also been partitioned into smaller pieces, increased by a factor of 5. So both items, the denominator and the numerator, were increased by a factor of 5. Smaller pieces, we just have more of them by a factor of 5. So 5 times 1 is 5, and 5 times 2 is 10. We all know that rule as n over n times the fractional part. All right, so the question is to give students repeated exposure to this so they come up with what's happening every single time. Is there a rule that we can use that to create equivalent fractions that will work every single time? We all started, when I learned math, with the rule, and then we had to like mesh it with the visual model. So my challenge to you is, can you start with the visual model and help the students uncover the rule? They're creating the sense making. So the rule is n times a on my numerator and n times b. So my fraction is a over b, and I can create an equivalent fraction by multiplying the numerator and the denominator by the same factor. Okay. All right. So let's see. Here's another one. So I had 1/4. If I partition into fourths, here I have 3/4. 3/4 occupies the same spot as 6/8 because all of those pieces were partitioned into 2 smaller parts. So everything was increased by a factor of 2. 2 times 3, 2 times 4. Okay. All right, so there's the rule. We want to come at the rule from the visuals. Awesome. It's time for our first breakout, everybody. All right, so what I'd like you to do is get that fractions breakout handout. You're going to use pages 1 through 4. I don't remember what time. Is it 9:47 already? Okay, we're coming back in 5 minutes.
You want me to change that time to 5 minutes?
Yeah, what did we have? 8, I think.
We had 8 plus 2 for a total of 10. What would you like this?
Yeah, let's just do 5 minutes.
Okay, and then just come back right away after 5 minutes?
Yeah.
Okay, I'm going to make that change really quick, and then I will put everyone into their breakout.
Love it.
Okay, that was super cool. The Jamboard thing. That was really fun. Okay, awesome. I know that was really short, but I think what I saw in my room, everybody was doing equivalent fractions. So good job. Okay, another model to show equivalent fractions is a regional model. And this is actually page 4 or page 5 in your handout. So if you want to flip to that page, we're going to do this, and I'll do it on the document camera. But what I'd like for you to do is actually shade, take the first rectangle, and shade 3/4, so 3 pieces of size 1/4. I put a number line there so you can actually connect it to the number line. So 0 and 1. I need 4 equal parts. So I can shade up to 3/4. Okay. All right, so that's 3/4. And now I want to draw slices. So I'm going to just take this. I'm not changing the fractional part, but I'm just going to draw a slice. And I partitioned it into 2 equal sections. I didn't change the amount I shaded at all. All I did was make smaller parts and I made more of them. So how many parts do I have all together? 1, 2, 3, 4 on the top, 1, 2, 3, 4 on the bottom. I have 8 parts all together. So I have 8. How did I get from 4 to 8? Times 2. And how many parts are shaded? 6 parts are shaded. Whoa, how did I go from 3 to 6? Oh, times 2. And then on the number line, we can do the same thing. So I have, all I did was partition each one of my fourths into 8. So I have 8 parts. So I have eighths. I have 6 eighths, 6 eighths. I traveled 6 pieces of size 1/8. Okay. All right, let's do it again. So shade 3/4 on the next one. Same one, 3/4. So I've shaded, I have 3/4. And now I'm just going to make slices. This time I'm going to do 2 slices. All right, I'll let you fill in the bottom. What's your new fraction? And what did you multiply the numerator and the denominator by to get that new fraction? These are the questions to ask. Did the shaded amount change? No. What changed? The size of the pieces. The number increased by a factor of, this time they increased by a factor of 3. I have 12 pieces and 9 are shaded. So they were all increased by a factor of 3. So do this repeated times. And then the last question, what's the rule that works every time? And the rule is I multiply my numerator and my denominator by the same factor. Okay. All right. So you've got 2 ways to help students understand equivalent fractions. With that, slices. Okay. Great. All right. Any questions? Oh, I need to reopen the chat. Sorry. You know, when we do the breakouts and then it comes back, like everything goes back to how it started. Yeah, yes, Andy, thank you. And n is equivalent to 1. Absolutely. So we're not changing anything. We're just, it's the same fractional part. We just have it in a different form. Excellent. Excellent point. Great. Okay, so let's use this. So in level C, which is 5th grade, they're adding fractions with unlike denominators. And the wording is actually, they have to replace given fractions with equivalent fractions. So I'd like you to go ahead and solve this problem. Try to do it on a number line or try to somehow do a visual model to come up with your equivalent fractions. Maggie paddles her kayak a half mile to an island. Then she paddles 4/5 of a mile to a beach. How far does Maggie paddle her kayak in all? So go ahead and solve that. And you can put your answer in the chat when you are ready. I won't make you wait this time. I've got a couple different ways you can express this. 13/10 or 1 mile and 3/10. Is that the same? 13/10, 1 mile and 3/10. Awesome. All right. So let's take a look at what this might look like on a number line. So we have same size parts. Tenths are kind of tricky. So I do the trick where I start halfway and then I look on the left and I make 5 equal parts. And then I look on the right and I make 5 equal parts. But here is my 1/2 that she paddled or she walked. She did something. She did something for a half mile. And so I have a 1/2 plus 4/5, but I don't have the same size parts. So I'm going to have to replace these fractions with given fraction, replace the given fractions with equivalent fractions. So I have the same size parts. So I'm going to need something that can be partitioned in halves and fifths. Tenths work. So I need some tenths. So on this one, I do this halfway. I look at the half and I partition half into 5 equal parts, and then I partition the other half into 5 equal parts. Making tenths is a little bit complicated, but I just try to do, I do fifths on one side and fifths on the other side. I get my 10 equal parts. Okay, so if I start with halves, at 4/5, that's equivalent to 8/10. So I'm going to start making my jumps. I'm just go there's 2/10, there's another 2/10. Oh, I don't have 2/10. So I'm going to need some more tenths. So between 1 and 2, I need to partition into tenths and jump 4 groups, 2/10 each. And I land on 13/10, which occupies the same spot on the number line as 1 mile and 3/10 more. And that's what we want students to know, that they occupy the same spot. And yeah, and it's okay. An improper fraction, they can rename it into a mixed number, but I think really we also want them to see, I can go beyond 1 whole and I can count these unit fractions: 1 whole, 1/10, 2/10, 3/10, 13/10. So it's totally fine for them to see it both ways. So fantastic. And you're right, Andy, improper is not wrong. It's just a different representation. Absolutely. And actually in the elementary standards, there is no mandate that they rename them to mixed numbers. So we want students to notice that they occupy this. All they need to know is they occupy the same spot on the number line. 13/10 is the same as 1 and 3/10. It's okay. Great. Awesome. All right. So let's move on to multiplication. So we are going to work with some language. When we talk about multiplication, try to get in the habit of using the term groups of. So as in 3 groups of size 2. 3 groups of size 2 would be 6. And we can show this as 3 groups of size 2. I have 3 groups, there are 2 triangles in each group. On the number line, starting at 0, I make a jump of size 2. I make another jump of size 2. I make another jump of size 2. 3 groups, 3 jumps of size 2, and I land on 6. So this is the language they're using in elementary school to talk about multiplication. And it works really well when we talk about fractions. Okay, so in this problem, James is baking cookies. 1 batch of cookies uses 2/4 of a teaspoon of vanilla. James wants to make 3 batches of cookies. How much vanilla does James need? So we can see we've got the 1/4 teaspoons. And so they've done a visual model of the 2/4 for each batch. And then we also see the bar models on the bottom, where each batch has been partitioned into 4ths and we're shading in 2/4. Okay. So let's just practice saying this. This is 3 groups of size 2/4. So go ahead and say that out loud to your computer. 3 groups of size 2/4. Okay, so 3 groups of size 2/4 would be 6/4. So let's take a look at this on the number line. So in this one, I've partitioned, I have my 0, I have 1 hole, I have 2 holes, and each hole has been partitioned into fourths. So I start at 0, I jump 2 fourths, I jump another size 2 fourths, and I jump a third group of 2 fourths, and I land on 6 fourths. Okay. Awesome. All right, go ahead and try this one on your own and use a number line. The family eats 3/8 of a box of cereal each day. What fraction of the box of cereal does the family eat in 2 days? So go ahead and do that on a number line. Partition into eighths. All right, go ahead and type your answer in the chat. Ooh, look at you, mathematicians, coming up with all your fancy representations of the fractional part. Whoa, nice work. Nice, nicely done. All right, so hopefully you have a number line drawn. 0 to 1, partition into eighths. We start at 0. I need 1 jump of size 3/8. I need a second jump of size 3/8, and I land on 6/8, which occupies the same spot on the number line as 3 fourths. Good job. Great. Okay. So here's your next task. Use a number line to prove, say this out loud in your head or to your computer, 3 groups of size 2/5 is the same as 6 groups of size 1/5. Is that true? So go ahead and draw some number lines to prove that. Okay. How did we do? While you were working, I dropped a flyer in the chat with, I think this one is on there, but then also some other K8 math, K5 math sessions. So feel free to sign up for whatever you'd like. It's all free. Great. Okay, so let's go ahead and show. So on my top line, you could do this any way you want, but I just did 1 line on top, 1 line on the bottom. You might have done 1 line and partitioned it. That's fine. So on my top line, I have the 1 and the 2, and I partitioned each hole into 5 equal spaces. So on my top line, I did 3 jumps of size 2/5, and I landed on 6/5. And then on the bottom line, I partitioned it into fifths as well, but I did 6 jumps of size 1/5, and I landed on 6/5. Now, the question for kids is, what's the relationship between the 3 and the 2 and the 5 and the 6 and the 1 and the 5? Like, what's the relationship and our answers? Is there any kind of relationship going on? And hopefully kids will start to notice, oh my gosh, 3 times 2 is 6, which is where I landed. And 6 times 1 is 6, which is where I landed. So from this, we can get to a rule, but again, it's from the visual models. Okay. All right. We're going to head into breakout number 2. This time you're going to start on page 7 of your handout. And then we'll be back. So let's see, how much time? Let's do the 10 minutes. What did we have? Let's do whatever we had originally. Let's just
We did too. And we got into the second question, and then it's like, oh my God, bink, we're done.
Was that the one about Kareem walking 3/4 of a mile for every
Yes.
day?
And what we did, we introduced that since I think it was Lindsay or Laramie, the person that had answered A, and that was, the incorrect answer. What question could we have asked where that would have been the correct answer? Right. So we took the side shift here and said,
Cool.
what could we have asked?
And what kind of questions did you get? What did you ask?
Well, the big one was that we circled the question was, how many miles did Karami walk altogether? And we said the altogether is the important word there. That means that we're talking about all of them. If we had just taken the exact same thing, the exact setup, the exact question, but just took all together and changed it to each day, then Lindsay is correct.
Oh, that's cool. So she walks 3/4 of a mile. It's
Each
between
day.
0 and 1 each day.
Yes. Right. But the students can look at
Cool.
what is the information, what questions could they ask me? And then what questions did they actually ask me?
Awesome. And so on that one, it was how many days? They walked 3/4 of a mile. Three-fourths of a mile for 5 days, right? So you end up with 15/4. So that one, as I was watching it unfold on the Jamboard, that might be a problem to do after you've done simpler problems and they've established that rule, which is the second rule. N over A groups of B is N times A over B. So that would be the multiplying of my number of groups. In this case, it was 5 groups. And then each group is 3/4 of a mile. So it's 5 groups of 3 over 4. 5 groups of 3/4. So we end up multiplying our whole number, our coefficient really, with that numerator. And that's that rule. That would make that problem, that Kareem problem, you had to do a lot of drawing on that one. So I would probably have to do smaller problems, less, with less drawing of things, so they can establish the rule and then use that problem maybe to apply that rule. So I apologize for that one. So some of the rules we talked about that we want to help students derive from the experiences with number lines. A over B is A multiples of 1 over B. So 3/4, perfect example. I start at 0, I travel 3 pieces of size 1/4. So I land on 3/4. So it's 3 repetitions or 3 groups of 1 over B, which gets us into the second rule, which is 3 groups of 1 over B would end up being 3 times 1 over B. And then with our equivalent fractions, we had the same factor that we're multiplying our numerator and our denominator by. Now that hopefully will not be confused, because sometimes I see students do this. Like let's say it's 1/10 and I want to make that 5/10. Well, it's 5 times 1 and 5 times 10, not 5 times 1/10. Because then that is like not making an equivalent fraction. So it's 5 times 1, 5 times 10. So n times the numerator, n times the denominator. All right, one more multiplication problem. How would you read this? Knowing how, we've been talking about multiplication. So read that out loud to your computer. I don't know what you said, but here's how you would read it. What is 2/5 of a group of size 1/2? What? So practice saying that. 2/5 of a group of size 1/2. because I don't even have a whole group. I have a half of a group. So it's 2/5 of a group of size 1/2, or 2/5 of a half of a group. So just kind of think about the wording there. And what would that look like? So I don't get the whole thing. I only have half of it. So we want to mark and shade the number line to show 2/5 of 1/2. So here I only am looking at 1/2. 2/5 of that would get me up to there. But what is that in relation to my entire whole? Well, I shaded 2/5 of 1/2, which would be 2/10. So here, from repeated experiences, we get them into that understanding of multiplying the numerators and multiplying the denominators. Does this happen every time? Those are the questions to ask. What do you know? What's the relationship between the 2, the 5, the 1, and the 2, and the 2/10? Oh my gosh, I noticed that 2 times 1 gives me 2, 5 times 2 gives me 10. Does that happen every single time? Is there a rule that we can create so we don't have to draw these number lines all the time? Okay. All right. So that brings us up. Oh my goodness, I only have 3 minutes. No. All right. We might have to cut our breakout, but we'll just do division really, really quickly here. Okay. So with division, there are 2 meanings. It's the only one where there's 2 meanings of the answer. It's either how many groups or how many are in each group. So if I have 20 divided by 5, my answer is 4. There's 2 meanings, and this like hurts my brain every time I talk about this. What does the 4 mean? Well, if it's 20 divided into groups of size 5, I have 5 people in a group, I can have 4 groups. So if I have 20 people and we're going to sit at a table and I want 5 people at a table, I'm going to need 4 tables, 4 groups. Okay. Or it could be 20 divided into 5 groups. So let's say I have 20, we walk into the restaurant, there are only 5 tables. How many can be at each table? 4 at each table. That like messes with my brain. So I'll leave you at that. You can think about that when we have a break here. Okay, we're gonna skip this. Let's skip this. Okay, so we're gonna do this. Eric has 4 pounds of blueberries to make into pies. How many pies can Eric make if each pie needs the given amount of blueberries? Okay, so draw a number line. Let's do letter A together. Draw a number line. He has 4 pounds of blueberries. So on my number line, I'm going to partition my whole numbers into equal parts. Starting at 0, I have 1 pound, 2 pounds, 3 pounds, 4 pounds as my end. So draw your number line ending at 4. Okay, awesome. All right. So the first one, each pound, how many pies can Eric make if each pie needs a given amount of blueberries? So a half pound. So on your first line, he's not going to use the whole pound of blueberries. He's only going to use a half pound of blueberries. So how many pies can he make if he has 4 pounds of blueberries and he uses a half pound for each pie? So 4 divided into size 1/2. 4 divided into groups of size 1/2 would yield 8 pies. So this is really similar to our butcher problem. But again, we're not going to come to the rule. We're not going to tell them a rule. We want them to come to the rule. So go ahead and try another one. Now do your second number line. How many pies can he make if he uses 1/3 of a pound for each pie? What would that look like on the number line? Okay, and after you've done that, you can do the 4th. Maybe you're finding like there's a pattern that's happening. What's happening every single time? Okay, so here is all of my number lines and circling, and I stopped after 16 pies because I got tired of circling. So I had 8, and then I had 12, and then I had 16, and I noticed, wow, it's like 4 was being increased by a factor, and the factor always seemed to be my denominator. So 4 was increased by a factor of 2 to give me 8. 4 was increased by a factor of 3 to give me 12. 4 was increased by a factor of 4 to give me 16, because each pound was being partitioned into smaller groups, and it was the size of my denominator. So I figured, oh, well, 1/5 of a pound is going to be 20, and a 1/6 of a pound is going to be 24, because I could just multiply by my denominator. What? So from the repetition, we can take these division. It's a division problem, but really, since I'm partitioning it into smaller pieces, I end up multiplying by that denominator. So the denominator ends up becoming a multiplier. Oh my gosh, nobody ever taught me that. But is there a rule we can do? Yes, we like to think about it as flip and multiply, but multiply by the reciprocal. But why does that work? Here is why. So I would take your students through this so that they can see where that comes from, because I just memorized it and I didn't really understand what was happening, but we're multiplying by that reciprocal. We can carry this forward where we multiply a fraction by a fraction. So even when we're multiplying a fraction by a fraction, it still is the same thing. When we multiply, we end up taking the denominator, and that becomes our multiplier, and the numerator becomes our divisor. So when we flip and multiply, we're actually increasing the pieces by a factor, and then we're grouping those pieces by what used to be the numerator. It's quite confusing, but you can get there from just a really simple exercise like this one, where they're practicing partitioning in repeated exposures. Okay, all right, we are at 10:30. So there were some questions in your breakout in this afternoon. Feel free to use those and whatever other problems I gave you to practice this. So when doing division, I like asking the question, how many groups of this size can fit into the larger number? Absolutely, absolutely. Thank you, Lorna. Absolutely. Yeah. Okay. All right. So what are we doing now? Am I at time?
Yes, so we can take a break, and then we'll come back and we'll do moving beyond cross, multiply, and divide. During the break, I'm going to add the links to our Jamboards, so you have those. And so that the Padlet is going to keep growing. So keep checking that. By the end of the day, you'll have lots of resources there. And you will also then get to see a couple of the problems for division that we didn't get to practice, but you can always do those on your own from that third breakout group. So anyways, take 15 minutes. We're going to start back at 14 minutes. We're going to start back at 10:45. And then we will start with round 2.